All right, hey team. So in this video, what we're going to be looking at is more of our 3D shapes. And we're actually going to be changing one of the dimensions or attributes of the prism or eventually down here to the cylinder. And so that's what you see in the title for today, that we can describe how changing one of these measured attributes, so again, the length, the width, or the height, and we're going to see how that would affect then the volume and the surface area of the prism, or down here again to the cylinder, okay? So let's just get started here. We're just going to find the volume of this prism. We like volume of prism questions because it's just multiplying length times width times height. So I'm just going to multiply the 7 times the 4.5 times the 5. And this is our current volume of 157.5. So the current volume is 157.5 cubic inches. Okay? All right, cool. Now comparing back to this original volume, if the length is doubled, how will that affect the volume? Okay. Now if the length is being doubled, our scale factor here, y'all, is a 2. We're only multiplying one of the dimensions by a 2. So if this is the original prism right here, if I double the length, I'm just saying make it twice as long. So that means basically it's going to hold twice as much, okay? So if the length doubled, the overall volume should double. So if we have the original volume, all that's going to happen now is it's going to double. So I'm going to do times 2. And now we have a new volume of 315 cubic inches. So when we changed one of the dimensions, how did that affect the volume? The volume doubled. So the volume, I'm just going to put V for volume, the volume doubled. Okay? Nothing too tricky here. The volume doubled. All right, next question. So we're going to stick with this original box here. Comparing back to this original volume, if the height is tripled, how will that affect the volume? So our scale factor in this case, because we're tripling the height, our scale factor is a 3. All right, let's go back to this picture. I don't want to double the length. I just want to make this thing 3 times as tall. So I have now tripled the height, so it holds 3 times as much. So again, nothing too tricky here. The scale factor is a 3. So how will this affect the volume? The volume is going to be tripled. And if I take my calculator and go back to the original 157.5, if I triple the height, then the overall volume is also going to triple, and I get a 472.5. So this is now 472.5. All right, cool. Now let's again, comparing back to the original volume here. If the length and the height both get doubled, what will be the effect on the overall volume? So let's go back to this picture here. Let me get rid of the height tripling example. So here's my original box. We said that the length is going to double and the height will also double. So if it's twice as long and twice as tall, do you guys see that there's now 4 boxes? So it's going to hold 4 times as much. So this time our scale factor is a 4 because both the length and the height got doubled. So this length, we did a times 2 here, and we did a times 2 of the height. So right here we can see the scale factor is 4. And what happens to the overall volume? The overall volume is quadrupled. I'm just going to put a quad for that. Or you could say in parentheses that it's 4 times as much. Up here for tripling, we could have said that it was 3 times as much. And up here for doubling, we could have said that the volume was twice as much. Okay, 2 times x. All right, cool. So if I were to ask you guys just straight up, what are 3 ways that you can triple the volume of a rectangular prism? Well, you could triple the length, just the length, or you could triple the width, which we didn't see that one, so I'll show you guys what that looks like over here for tripling the width. If this was my original box, if I triple the width, I'm just saying it's going to be like this. And now it's 3 times as wide, okay? It started out with just 1, and now it's 3 times as wide. So that would still triple the overall volume because there's still 3 boxes there, okay? So if I want to triple the volume of a box, I could either triple the length or triple the width or triple the height, which we already saw that with the 3 on top of itself. Now, if we're impacting more than one dimension at a time, okay, kind of like how we doubled here the length and the height, notice that the overall volume was impacted by the product here of those changes. So if only one dimension is affected, then the volume is exactly affected by that same scale factor. What I mean by that, y'all, is up here. If only one dimension was changed, then the volume changed by that exact amount. If the length doubled, then volume doubled. If height tripled, then volume tripled. Okay, that's what we're saying here. When one dimension is affected, the volume is exactly affected by that same scale factor. However, if more than one dimension is affected, kind of like in this example where the length and the height were both affected, then the volume changed by the product of the changes, okay? So the doubling of the length and doubling of the width, 2 times 2 is 4, so the volume was 4 times as much. If I go back to this original box and I say, all right, I'm going to triple, let's do all of these things. I'm going to triple, sorry, not triple, I'm going to double. I'm going to double the length, I'm going to double the width, and I'm going to double the height. All of them are going to get twice as much. So I'm going to go twice as long, okay? I'm going to go twice as wide. And now I'm going to go twice as tall. We count right there 8 boxes. Here's 1, 2, 3, 4, 5, 6, 7, 8. And the volume is 8 times as much. And right here, what's 2 times 2 times 2? It's 8. Okay? So if the length gets doubled and the width and the height, then the volume is now 8 times as much as the product. Okay? All right, now that takes care of up top, that takes care of if we're dealing with a prism. Now we're going to kind of do something similar, except we're going to explore what happens with a cylinder, okay? So first thing we're going to do is find the volume of this cylinder, and you guys know that to find volume of any cylinder, it's just going to be the area of the circle times the height. So we've got pi r squared and then times height. For this one, the radius would be a 2, so I'm going to do 2 squared. All right, now I'm going to do times pi. So that's the area of my circle. Now times the height of the overall cylinder, so times 8. So the original volume of this thing is 100.48. Okay? And we'll put cubic feet. 100.48 cubic feet. Now, if we compare back to this original volume, if the diameter is doubled, how is this going to affect the volume? Now, you might be thinking, if the diameter is doubled, then it's going to be double the volume. Let's see what happens here. I've got this all set up if you guys want to, this is just going to be you taking notes for the pi r squared. So the original one, we said here, the radius was a 2. So I had a 2 here. And I did pi r squared times the height. So my radius getting squared here was a 4. Okay. And when I did this math, this was the math we did a second ago in the calculator, I got the 100.48. So this is the original cylinder. Okay. Now, if the diameter gets doubled, that means the 4 across now turns into an 8 across. So the new radius is a 4. Now careful here, y'all. If I put in my new radius and 4 gets squared, this is now a 16. So what happens to the volume? It's actually 4 times as much, okay? Now the reason it's 4 times as much is because this radius right here, this radius got doubled. It was twice, and that doubling gets squared. So that right there is the overall 4 times as much that we're going to see. Okay. I don't even really, I mean, I could do the math right here. I could multiply this out, but I know if the number here is 4 times bigger here, the overall answer should be 4 times bigger. So if I do times 4, I get 401.92. So 401.92. Let's make sure that that's the same as if I just like multiply all the numbers out. Because again, all I did was trust myself and say, okay, I know it's supposed to be 4 times as much as the original volume, but let's prove it. Let's do the 3.14 times the 16 times the 8. Yep, and there's the 401.92. And you can compare that new number by just dividing it by the original number, and it'll show you it's 4 times as much. Okay? So if the radius is doubled, because the radius gets squared, okay? We're doing a doubling that got squared. So it's now 4 times as much for the volume. The volume is 4 times as much. While I'm on this idea of radius, let's just explore, even though it's not in here for the notes, let's just explore right here what would happen. Let's say instead of doubling the diameter, let's triple the diameter, okay? Let's triple the diameter. If it originally started here as a 4, now I'm going to make it a 12, okay? Which means my new radius is a 6. And even though this isn't in your notes, I just want you guys to see what happens here. The radius of 2, it tripled to a 6. Now because that 6 is getting squared right here, this is a 36. So do you see that the 4 is now getting 9 times bigger? And it's because my radius, I tripled it, but then the radius gets squared. So that means it's going to be 9 times bigger. And right here, you can see the 4 times 9, it's going to be a 9 times bigger. So just be very careful if I'm talking about impacting the diameter. It's not going to be as easy as it was up here. It's not going to be that simple because you've got to consider the fact that that gets squared. So one more example, let's say instead of doubling it or tripling it, let's say I did a times 4 right here. Well, if it's now 4 times longer, that 4 gets squared. So if you quadruple the diameter, you actually are making it 16 times bigger for the volume, okay? All right, now that has spent a lot of time there talking about what happens if the diameter changes, okay? I've spent a lot of time talking about what happens if the diameter changes. Let's just explore real quick about the height doubling. Well, if you take this cylinder and you just make it twice as tall, it's going to stack on top of itself. That's going to mean that the volume doubles as well, okay? Anytime the height's impacted, the volume is going to change by that exact same amount. It's really only the diameter that you need to be on the lookout for, okay? So then we ask this question here, will doubling the diameter have the same impact as doubling the height? No, no, it will not. Because if you double the radius gets squared. Getting squared actually means it's going to be 4 times as much. But in the formula down here, if you take this height and then just multiply it, let me actually delete this out real quick. If I just make this a 2h, commutative property says that that 2 could really come even at the beginning of all this multiplication. So it's just doubling whatever you originally had. So height doubling will impact the volume very easily. But if the radius doubles, you've just got to consider that square thing. All right. Now what you guys are going to do is you're actually going to flip over and answer these questions on your own. And those answers are going to go into a Google form. But before you do that, I want to talk briefly about surface area, only because surface area wasn't addressed in the notes. And I just want to talk about what happens if we change one of the dimensions for surface area. Unfortunately, there is no shortcut to this. If I have right now my surface area of this is supposed to be 2 times my 7 times 4.5. And then I've got 2 times my width and height, so 4.5 times 5. And then I've got 2 times length and height, which is the 7 and the 5. All right, let me just change the font size here so that's all in one line. All right, so this is my original surface area right here, okay? And I might say, hey, what happens if I double the length? And so this is now a 14. Well, if that changes, it's only going to change this right here to a 14, and it's going to change this right here to a 14. Okay? So this surface area stuff is going to double, and this is also going to change. This will not change. All right? So the only way we can really check to see what the change is for surface area is to calculate the original one and then calculate the new. So let's calculate the original surface area real quick with this stuff right here. 14, so I'm doing 14 times 4.5. All right, that's 203. Then we've got 2 times 4.5 times 5. So this is a 45. Gosh, that didn't feel right. Was that right? 14 times 4.5. That felt way too, yeah, that's only a 63. That's weird. Sorry about that. I don't know why I got that number a second ago. But yeah, that's only a 63. And then here, we know that 7 times 5 is 35, and double that would be 70. So we've got these three numbers to add up, and this is my original surface area. So this is a 178. Cool. Now for the new surface area, this is basically now 14, so it's going to be a 2 times a 14 times 4.5. This stayed the same, so I know I can just keep the 45. And then over here, this doubled to a 14, so I know this is also going to double. Okay. All right, so let's check real quick. Whoops, sorry about that. My little picture there. Let's get these notes back up. All right, so then 2 times 14 times 4.5 for this part. What is happening? I don't like that. Oh, I'm doing 14.5, not 4.5. That's why I keep messing this up. Okay, here we go. 2 times 14 times 4.5. There we go. So this is now 126. And again, I know this part wasn't in your notes, but I just wanted you guys to see that with this, there really is no shortcut. You just got to do the math and then the math again. And we're just going to compare the two numbers. And then a 140. So this is my new surface area, 311. All right, and this is the new one. So if I want to compare the new to the old, I can really just divide the new one by the old one. You could see that it's like 1.7 times as much. And there would have been no way to calculate how much more this grew into other than to say, all right, here's my original surface area, here's my new surface area. There will be a question like this on page 3, so I just wanted to walk y'all through that you basically just got to find both surface areas and then just compare. You can take the new one and divide it by the old one, and that's how you can compare how many times bigger it is. All right, that concludes this video. Thank you for watching.